And now guys, we are going to talk about the proportionality table. A table is proportional, or what we call directly proportional, equivalent to say that again and again, x over y equals k. What are x and y here? What is k? Let's remember. K is the constant or the coefficient or the rate or the ratio of proportionality. Now, what do x and y represent in a proportionality table? Consider the tables T1 and T2. These are tables. Notice you have two rows in these tables, a row for x and a row for y. So x and y are referring to values in these rows of these tables. Okay? So, if we divide every time x by y, like 20 by 30, minus 10 by minus 15, etc., this by this, this by this, and we get a constant rate or a constant number, the same number, we say that the table is a proportionality table. But if we didn't get so, we say that the table is not a proportionality table. So again, to check whether a table is proportional or not, all what we have to do is to divide x by y or y by x. But if we start by dividing from up to down, then we have to continue the same way. Okay? So we can divide either x by y or y by x. If we get the same number every time we divide x by y or y by x, we call the table a proportionality table. If we don't, we call it not a proportionality table and the rate doesn't exist. Let's start to check which one of these tables is proportional. According to T1, we start dividing x by y, then 20 by 30 is 2 over 3. Minus 10 by minus 15, dividing each term by minus 5, we will get 2 over 3. 0.2 by 0.3, pushing the decimal point, and here also we get 2 over 3. 2 out of 5 divided by 3 over 5, cancelling 5 together or making that way the exterior times the exterior divided by the interior times the interior, we also got 2 over 3. Thus, we say that T1 is a proportional table and its rate or ratio of proportionality is k, which is equal to that constant number appearing every time, which is 2 over 3. For T2, 200 by 400 is half. Radical 12 by radical 48 is 2 radical 2 by 4 radical 2, it's 2 out of 4, it's half. 0.1 over minus 0.2 is minus half. Whenever I find a different value, then I stop and I say that this table is not a proportional table, even if the difference is just a sign, as you see here. Here is an example on proportionality tables. Given the table T1, including these values, here is referring to x and this row is referring to y. All what I care about are these values: a over 50, minus 4, minus 10, 0.2b, and 1.2c. What's the question? What do you expect? The question here is, given that T1 is a proportional table, I have to determine its constant rate k and then to calculate the values of a, b, and c. So the table here is given that it is proportional. I don't have to check if it is proportional or not because I have missing, so I can't know. It is given proportional and I'm going to find its constant rate k and then to find a, b, and c. How do we find the constant rate? Can I find it by dividing a by 50 or by 0.2 by b or 1.2 by c? No, of course. To find k, I'm going to search for a column that has no missing. So I choose minus 4 and minus 10. So I specify k here that it is equal to x over y. and I search for a common that has no missings in it, and here I choose -4 and -10. Then k is -4 over -10 dividing by -2, it is 2 over 5, and this is the constant rate for this proportional table. Now how to find A, B, and C? Let's think a little bit. Think with me. How to find A? A is related to 50. So how should I benefit from that K I found? I write as follows. A over 50 is equal to this K. Why? Because the table is proportional. Then A over 50 is equal to -4 over -10 is equal to 0.2 over B is equal to 1.2 over C, and all of them are equal to K, which is 2 over 5. So A over 50 is equal to 2 over 5. Now all what I have to do is to cross multiply, then A equals 2 times 50, and we divide by the number facing A, which is 5. So 100 by 5, A is 20. So A is 20. Make sure, yes. Simplify 0 by 0, we will get 2 over 5 as K. Now for B, we take 0.2 over B equals also to 2 over 5, and cross multiplication 0.2 times 5 divided by the number facing B, then it is 1 by 2, which is 0.5. So if we substitute 0.5 and we push the decimal point, we will get 2 over 5. Now for C, 1.2 over C equals to 2 over 5. Again, we cross multiply. 1.2 times 5 is 6, divided by 2 is 3. So if we divide 1.2 by 3, we'll definitely get 2 out of 5. So this is how to solve things related to proportionality table. We can find missings if we know that the table is proportional. Another example, consider this proportionality table. We have to find the natural numbers x and y, knowing that x is less than y, such that this table is proportional. So here is the proportional table T, and I need to find x and y that are natural numbers, and knowing that x is less than y. Proportional table means x times y. This is another way of dealing with proportionality table. This is the cross multiplication sign here. Then x times y equals to radical 10 plus radical 7 times radical 10 minus radical 7. So another way of dealing with proportional tables is solving such questions. We have this table that's divided into 4 parts. Then if it is a proportional, then each two facing parts, when multiplied to each other, will be equal to the same result of these two parts when multiplied with each other. So this is the cross multiplication sign in order to make things clear. So x dot y should be definitely equal to radical 10 plus radical 7 into radical 10 minus radical 7. Now using the identity of a plus b into a minus b, I just square the first one minus square of the second one, then I will get 10 minus 7. So x dot y is equal to 10 minus 7, which is 3. Now I'm searching for two natural numbers whose product is 3. Natural numbers have no decimals, no radicals, no minus signs, just natural numbers. And x is less than y, then definitely x is 1 and y is 3. Since 1 is less than 3, then because x is less than y as given here. So x is 1 and y is 3. Another example. This is the table T prime. This is the table here. The question now is to show that this table is a proportional table. Again, I use the cross multiplication method because I just have 4 boxes. So I multiply these together and these together to get the same answer. Now making some calculations, I'm going to get here 15. Okay, notice the calculations. I find the answer of this, which is 4 plus 9, etc. And multiplying these together also, simplifying the radicals, getting these out of the radical and simplifying 0.08, you get these values as you see here. You get 5 radical 3 times radical 3, which is 15 also, and thus T prime is a proportional table. So, proportionality tables have two kinds of questions to deal with. Either you have to find the missing knowing that the table is proportional, or you have to show that the table is proportional. So, in all cases, you can either divide up by down, or as in the previous examples, or you can cross multiply as in these examples. When tables are divided into 4 parts only, you'd better use the cross multiplication method as you see here, doing some calculations, and you will definitely get the same answer. Whenever you get the same answer, then you prove that the table is proportional. Here, the question is a little bit different. You have that the table is proportional, you have to find the missings. Also, we use the cross multiplication because the tables are divided into 4 parts.